Hey everyone, thank you for joining us today. I'm Claudio Palais, Senior Content Manager for NetBrain, once again joined by my colleague George Lagarakis. Today we'll be looking at network security automation. What's the current state of events in the world of security? How operations teams can confront the regulatory compliance challenges facing them? And how automation best practices can be implemented to secure our hybrid networks. Later, George will take us through a live demo on how to enforce network security compliance using NetBrain's no-code automation. And finally, we'll open up the webinar to a quick Q&A session at the end, so be sure to write down any questions you might have during the presentation. And without further ado, let's start with a 2021 report published by the Identity Theft Research Center that found there was a new record in reported data breaches worldwide, with over 1,800 data breaches surpassing the previous year's total by 68%. And cloud migration only complicates matters further. As reported on their annual cost of the data breach report, IBM discovered that for those teams without security automation, it took them an average of 239 days to even discover that their cloud networks had been breached. And then it took them an additional 85 days after that to contain the breach. That's 324 total days under a breach, and even longer for a return to normal operations. And what does this mean in terms of impact? Well, one way to quantify is financial cost. In 2022, IBM reported in that same report that the global average cost of a single data breach was $4.35 million. And that picture looks even worse in the US, where that figure more than doubles to $9.44 million. And what are the challenges our security teams are seeing on the ground? In our own informal LinkedIn poll this past month, our respondents indicated their biggest problem with network security is regulatory compliance. But pretty much all facets of network security receive significant votes, suggesting security is a problem across the board. So what's been the strategies to confront these challenges? First has been a focus on device health in monitoring, maintenance, and operation. This strategy seems logical on its face. We have very expensive machines deployed to implement our security design, so it should follow that we'd want to protect the health of our investment. But if the configuration and performance of those devices do not match the design intent, the effectiveness is lost, even as health appears optimal. We're talking configuration drift, out of compliance or suboptimal settings, and degraded performance. Often these huge vulnerabilities go undetected until it's too late. Device health is not network health. Next, to address the gap between device health and actual security fitness is the bread and butter of most NetOps and SecOps organizations, incident support. When end users notice problems our device monitoring tools don't, they report it to our ITSM systems. Engineers respond, investigate, and resolve those one-off issues. But the premise itself is the problem here. In the world of security, when end users begin experiencing issues, it's already far too late. Your network is compromised and the business has likely already started losing money. And worse, most issues troubleshot aren't truly one-offs, meaning repetitive work that spends resources and time, leading to delayed incident responses, which in turn leads to a ticket backlog. Add in the additional time delay when escalating more complex issues, and your MTTR averages start to suffer, leading to more issues reported. It's a vicious cycle that's hard to escape. All of these represent reactionary procedures and protocols, and we know it doesn't scale. As the network and business expands, we can keep adding staff and resources, but you get to a point where you realize something. Experts are not an infinite resource. We have to evolve if the business is to grow. But what does that entail? What can we do to confront these challenges? Number one is expanding visibility. You can't manage what you can't see. But for large networks, how does that scale? We know adding every individual network component to our monitoring systems is cumbersome and time intensive. Automation is the only answer. NetBrain automates the discovery of the entire network and builds a digital twin. Our multi-vendor support and dynamic mapping technology means no corner of your network goes unobserved. Two is capturing your subject matter expert knowledge. Nothing can ever match the creativity of human problem solving, not even AI. Why wait months or years nurturing AI to learn your network when unmatched expertise already resides in-house? But where humans come up short is efficiency and persistence. Experts need to rest and aren't always available. Better then to digitize the human experience and pair it with machine efficiency. That's our network intent. Digitize your security designs, how your network should operate. Should traffic take path A or path B? Are remote users allowed to access this database? How should the ACL enforce that? Capture troubleshooting experience. What steps or actions did we take last time to resolve this issue, or a similar one? Network Intent captures all that intelligence and makes it available 24/7. Three is sharing that knowledge across the organization. NetBrain provides easy digestion of maps and intents to empower all levels of network support to resolve situations without escalation. That's our shift left philosophy. Identify root cause and resolve issues earlier in the escalation path. It's a de-escalation. Next is using these intents as executable tasks. Pair human decision making with machine speed. Eliminate repetitive workloads and significantly reduce mean time to repair. Basically, take an action that would take a human minutes or hours and have the machine do it for you in seconds. These aren't scripts. NetBrain is 100% no code. These are previously captured steps and actions saved as intents that can then be replayed and applied to a completely new situation or new part of the network. Once an intent, that expert knowledge, is captured, it's available to your entire support infrastructure. And now you're ready to use those intents proactively. Our research indicates half of all incidents are repetitive in nature, meaning that the same or similar issues have been reported in the past. We know how to solve these issues when they arise, and now we have the solutions captured as executable intents. Sometimes it can take hours for someone to respond to a ticket. Why not have those resolution steps execute even before an engineer responds to the ticket? You can have problem-solving automation triggered as soon as an incident is reported to your ITSM. No human intervention needed. By the time a support engineer acknowledges the ticket, NetBrain has already provided the root cause and recommended resolution steps. You can see all that from the ticket itself with our APIs and deep integration with the leading ITSM providers. Finally, we want to get to a point where we're preventing problems. Why wait for security breaches? Continuously verify and validate every part of your network and security infrastructure. Those same intents used to share knowledge and troubleshoot can be leveraged to enforce security compliance. We know that our HA firewall should have mirrored configurations to perform properly. We know that the ACLs in our network should always have a certain set of rules. Why wait for an HA failover or a security breach to discover that configuration drift has left us vulnerable? Use NetBrain to periodically and automatically test the intent of your network and alert you when security is out of compliance. Before we dive into the demo, I'll leave you with this. Half of all respondents to Informatech's 2022 State of the Network Management Report indicated security is their top network management priority, making it the top priority by a wide margin, with visibility and reducing costs tied for second at 18%. So we know security is huge, but what's held NetOps and SecOps back is getting the right tools into the right hand. And NetBrain's no-code automation is that tool. So let's see it in action. What does intent-based network security automation look like? George here will take us through a couple of typical automation scenarios that I know will be incredibly illuminating as always. So George, take it away.
Thanks, Claudio. So I'm going to take you guys through two different examples for how NetBrain can help with assessing network security, and also doing these assessments continually to ensure you don't drift out of compliance or into a state where you're insecure. So the first example I have brought up here, we're looking at a small branch site, right? Maybe think of it as a school or a small branch site for the organization that you work for. What I want to do here is I want to evaluate each device and look at device security. In particular, in this case, I want to ensure that these devices can only be accessed via SSH, and that SSH version 2 is the protocol that is configured. So how can I do that from here with NetBrain? Well, once the automations, once I've built my automation, it's as simple as going to the looking for my automation, selecting it, and now what NetBrain's going to do now is start creating that automation for those devices that are on my map. And once the creation is complete, I am then going to be able to execute the automation on demand. So now it's created for those 5 devices that I have on this map. Now with one click, I can execute it. While this is executing, let me take a moment to understand, help you understand what has brought us to this point. We created this automation to look for these security issues. And what we've also done is, with minimal complexity, scaled the automation out across the entire network to allow it to be run on any devices that we want it to, or that can support it. And now we can do things like this, where I can create the automation and then run it and see the result, which will appear in this pane in just a second, here we go. And I can read it here, but if I had a map of, let's say, 25, 30 devices, this might be a bit inefficient. So what I could do is I can actually click on this little icon and overlay my result right on top of the map. Now, how great is this? I can actually just look at a device and understand the device security situation in terms of telnet enablement. So in these two devices at the top, telnet's disabled, which is great, but SSH version 2 is not enabled. So that has to be remediated. On my devices on the bottom, this device is all good, right? Both of the checks came back good. That's great. This device, unfortunately, we need to address both issues. We need to disable telnet and upgrade it to SSH version 2. Now, it's all nice that I can run these checks on demand on top of a map. But the real power and the real thing I want to do is continuously run this check to ensure that after I make the changes, they don't drift back to a state where they're out of compliance and allow these insecure protocols, right, like telnet. So what I can do is set up what's called a timer and execute this automation on a timer. So that means I could have this automation executing on a preventive basis, whether that's every night, whether that's once a week, compliance checks, whatever fits my environment. Once that is done, or once that happens, if that alerts are generated, I can receive them like this through an email. So now I can see that telnet was allowed on a device, or is being allowed on a device. Here's the device name, and I even have a link to view the detailed execution of the automation within NetBrain. And this email can be sent to, here we can see it was sent to myself. I could also have had it sent to my team's email inbox as well. And another option, if you so choose, is to have this email sent to your ticketing system and have your ticketing system open incidents based on these emails being received, which could be good, for tracking these as well. So that's how the example works from A to B, right? Being able to do it on your own and then being able to have NetBrain run it automatically through preventive automation. But let's talk about what is powering this automation. So I want to take a look very quickly at the automation behind it. So I'm just going to search for it here and pull it up. And we're going to notice something right away, which goes back to replication. And that's the first element, the device, is a device that's not actually on our map. And of course, the other element here is the data, which in this case is the running configuration. We also have then the diagnosis logic, which is our third element. And this automation was built without any scripting. It is a no-code automation, as is all automation in NetBrain, right? It's a no-code automation. So what we've done is we've looked through the running configuration and specifically looking at the virtual terminal line configurations. And what we want to see is transport input SSH, right? And also looking at the running configuration for IPSSH version 2. And if we look at the logic, and I'll just do it this way, we're looking for transport input SSH, right? So if this protocol, which is, I'll go to my summary here, this part here is not SSH, then we're raising an error because that means telnet's allowed. And then also we're looking for that configuration line. If it exists, then we will have the green message. If it didn't exist, we'd have the red. And the way we parse out those variables, again, is a no-code way where all we're doing is defining which parts we want as the variable, like that protocol. And then NetBrain does the rest, and we can just simply insert it into our logic as we build it. So that's how this check works. And it's a very simple check, but it's a very effective check for any network. Now, the other part here is the replication. And we did this through what's called a template. And essentially what we're doing here is we're telling NetBrain what qualifications does a device need to have to be able to, support and execute this automation. So in this case, our qualification, because these are Cisco devices, is as simple as looking for Cisco switch, Cisco router, Cisco IOS XR devices, basically any Cisco routing or switching device. We can also tell NetBrain to look for things like critical variables. In this check, where we decide to look for all of them, but that could be done on a case-by-case basis based on what your automation is looking for. And with that, that's all you need to replicate the automation. Because within our intent library, we can actually run a process to look across the network and compare that template to see how many devices can support that automation. And if I look for that secure remote access check that I've been showing, I can see that NetBrain's found 250 devices that are capable of running this automation. And also from here, I can set up that timer. So here I can say, I want to execute this intent on a timer. We can do it as often as every 15 minutes, but we could do it, weekly, daily, bi-weekly, whatever fits your environment and your policies. And so I could pick one, and then I could set the, this is where I would set up the email that I could send the alerts to and things like that. So with that ends the first example I wanted to show you. So now I'm going to dive into a second example, and this is focusing on edge security. So I'm going to open a map here. This is a map of a core site, and it has connections to 2 client sites. Now the core site could be a provider, if you work for a provider, or in a lot of bigger enterprises, they'll have a lot of B2B connectivity with third-party vendors that look something like this, where they can see their own edge, the provider edge, and may have a device at the client edge as well. The idea here, what we're going to check for, is ensuring traffic separation, right? So ensuring VRF separation. And this will ensure that traffic does not leak from one layer 3 VPN or MPLS connection to another. So what we're looking for at the base is that each interface should have one VRF configured. And even further, it should match our design and should be, the VRF that we expect. So just like the other example, I can go over to my on my map here and execute that automation for the devices that are on this map. So again, I build it, and then once it's built, I'm able to execute that automation. And then subsequently, after execution, I could overlay my result on top of this map. And again, as before, we could have this check running in the background as well to alert us if any traffic separation issues do occur. So once this check is done executing, as before, we'll get the result and then be able to overlay it onto the map. So here's our result, a lot of green, and we can overlay that on the map. And now I can see that everything is green and is assigned. So pretty good. Now, what's different about this check is we're using another part of NetBrain that allows NetBrain's automations to be even more customized to your environment. And that's something called the global network data table. What is that, right? What does that mean? Well, simply put, it's this ability to define elements or critical parts of your network and then use it in automation. So with the table, in this case, what I did is I defined each interface for my devices and the VRF that I expect to be assigned to each interface. Now, I could have added also a column for devices, but in this case, I kept it straightforward. So in this case, if I have a device that has VRFs enabled, I would expect, for example, the Ethernet 03 interface to be on VRF2, right? Per our configuration standards and policy. So now having that table, what I can do is within my automation, which I'll show you here, I can actually use those values as part of the logic, right? And part of my building my variables that are used in the logic. So I can make them part of a table. And now when I look at my logic, I can use that information and say if the VRF that I see in the configuration does not match what's assigned, which is from that table I showed you, then I can have an error message, right? Or if I don't find anything wrong, then you can get the valid message. But now we're able to use our own network and our own networks, and our own custom policies in our network, along with the automation to make those automations even more custom and in tune with our environment. And of course, while also being able to check these critical security and design definitions and ensure no issues, are found. And we're also catching any issues before they become a problem, right? You catch a device with telnet open, and hopefully you're resolving that before someone uses it for malicious activity. You're catching this before it causes problems with your connections. And with that, that wraps up my little demo here of the two examples. And I'll pass it back over to Claudio to wrap up the webinar.
All right, thanks, George. As always, fantastic work by our demo team. One thing I like so much about NetBrain is how visual network management can be. Seeing the intent results right on the network map makes it so clean and easy to spot issues at a glance. This isn't sifting through CLI output or tables in a report. It's real metrics right on top of your devices in your map. Amazing. Now, before we open it up for Q&A, we wanted to thank all of you again for attending, and we wanted to share this scannable QR code that'll take you to schedule your own demo or allow you to check out our new guided tours at your own pace.